This is Module 1, Engage New York, Module 1, Lesson 14. Lesson 14, we are starting with concept development. All right, so we now are dividing 6.72 divided by 3. So this is going to be our dividend, and this is our divisor. So go ahead and write the word dividend and divisor, because those words are going to show up. And this word is quotient. So sometimes you might be asked on a quiz or a test or something you run across what the quotient is. And the quotient for a division problem is the answer. The divisor is what you're dividing something into, and the dividend is what you are actually dividing up. So let's go. We are going to divide 6.72 into 3 equal groups. So if we divide 6 into 3 equal groups, and we divide 7 into 3 equal groups, that could get tricky. And if we divide 2 up into 3 equal groups. So we're going to now take 6.72 and divide it equally into equal parts. So how are we going to start this? What should we do first? You're right. We are going to use the place value chart. So let's start with our larger number, and let's divide 6, the number 6, it's a whole number, into 3 equal parts. So we're going to divide it up into equal groups of 2. Now we're going to, from there, divide our 7 into 3 equal groups. Now, how would we divide 7 into 3 equal groups? How can we divide 7 into 3 equal groups? What do you think we should do? Anyone? Watch me. All right, we're going to share 7. We're going to give 2. We're going to divide it up. How many tenths do we have left over? How many tenths? So we divided 7, we divided 2, 4, 6. We divided it into 3 equal groups, right? So how many tenths do we have left over? Show me with your fingers. How many tenths do we have left over? You can respond. What can we do to keep sharing? We're going to change 1/10 into 10 hundredths. So we're now changing this 1/10 into 10 hundredths. So we're now giving this guy 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We just now gave this one 10. So when we move this 1/10 over, we gave this hundredth, we gave it 10 hundredths. So remember, if you took 10 hundredths over here and moved it over, you would give it 1/10, right? So now we're passing it back, and we're giving it 1/10 for 10 hundredths. So now we have 12. So we have this 2, so we're going to add 2. We're going to add the 2 here. So now we have 12 to divide equally between 3. Okay, so now we have 12 we can divide up equally into 3 equal parts. So 12 divided by 3 would give us 4, right? 1, 2, 3. So we have 3 groups of 4 because we now ended up with 12. 12 divided by 3 is 4. So our answer is going to be 2.2, because look, there's 2, and now 4. That is our answer, 2.24. We have 3 groups of 2.24, and if you came over here and went 2.24 and you multiplied by 3, let's see what answer we'd end up with. So we'd end up with 6.72. That is what we started with. So we know we divided this correctly into 3 equal parts. Now, here is standard algorithm. Let's do it. 3 divided 6 is 2. 2 times 3 is 6. Bring down the 7. And you know what I'm going to do? I'm going to move this decimal straight up. Now, 3 goes into 7 how many times? 2 times 2 times 3 is 6. Subtract. 7 take away 6 is 1. Bring down the 2. How many times will 3 go into 12? 4 times. So, as you can see, we divided it up using place value understanding. We divided it up with standard algorithm, and we checked to make sure that 2.24 was correct because we used the inverse operation and multiplied 2.24 times 3. We did the inverse operation, 2.24 times 3, and we ended up back at 6.72. All right, let's go on to problem 2. 5.16 divided by 4. So 5 and 1600ths divided equally into 4. So let's go ahead and try to figure out how we can divide 5.16 equally into 4 equal groups. Okay, so how about if you guys, what do you guys think? Let's try it. So if we say, well, let's divide this into 4 groups. I have a 1, 2, 3, 4. And now I'm going to have 1 left over, right? So I'm going to take this 1 and I'm going to pass back a group of tenths. So now I'm passing back, because remember, once you get 10 over here, you have to move it over here and you get 1 new group. So when you pass it back, you're passing back a group of 10. Okay, so I have 10 here and I have 1 here. So now I have 11. So now how am I going to break up 11 into 4 equal groups? What do you think I should do? I could do 2, 4, 6, 8, and then I would be left with a few left over, and I could pass it back. So let's say I have 1, let's go, here's a group of 2, here's a group of 2, here's a group of 2, here's a group of 2. So 1, 2, 3, 4, I have 3 left over. So now I'm going to pass that 3 back, and I'm going to end up with 3, I'm going to end up with 30. I'm passing back 30. So why don't I just write 30 instead of drawing all those dots? 30 plus 6 gives me 36, and now I have 36, and I need to divide it equally into 4 equal groups. How many are going to be in each equal group? Show me with your fingers. So we have 9. We're going to divide 36 into 4 equal groups. You're going to get 9 in each group. So our answer is 1.29. That is our answer. Now, if we want to go back and check to see if we are correct, you could say 1.29. So 1.29. And I'm going to use the inverse operation. Instead of dividing, I'm going to multiply to check my answer. 9 times 4 is 36. 4, 5, 6, 7 plus 4. And I have 2 numbers behind the decimal. I have to put that back. Wait a minute. 4, 8, 9, 10. Oh, I forgot to add the 1. Sorry. So 5. Oh, I don't know. I was talking crazy talk right here. 5.16. So yes, 4 times 2 is 8, 9, 10, 11. Put down the 1, carry the 1. 4 times 1 is 4, plus 1 is 5. 5.16. So yes, using the inverse operation, I was able to go back and check my work, and I was able to check myself. So now let's use standard algorithm. 4 goes into 5 one time. 1 times 4 is 4. Subtract, bring down the 1. Now I'm going to put that decimal up there immediately so I don't forget about it. 4 goes into 11 how many times? 2 times. 2 times 4 is 8. Here is 3. Bring down the 3. So do you see that this 3 is really that 3? And we added 6 and it became 36. So it was really 30 plus 6 is 36. 4 goes into 36 9 times. That's how this all comes together. All right. Let's try problem 3 and problem 4. And then we're going to go on to our problem set. So 6.72 divided by 4. All right, so we have 6 and 72 hundredths. Divide into 4 equal groups. So let's start with our 6. How are we going to divide 6 up into 4 equal groups? All right, so I'm going to use, and I am going to use just whole numbers. I'm going to say 1, 2, 3, 4, and I'm going to have 2 left over. Yes? Okay, now let's pass back. We're going to need to pass back these 2. And when I pass back those 2, I'm really passing back one group of 10 and another group of 10. So I'm really passing back 10 and 10. Now I'm going to add 7 to it and end up with 27. Now I'm going to take 27 and divide it into 4 equal groups. How many would be in 4 equal groups? It would be 6, because if I divided this into equal groups, if I divided this, it wouldn't go evenly. So the closest I could get would be into 6s. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And that would leave 3 left over. So now I need to pass back 3 over here. But that 3 really becomes 30. And it would be, so each one of these would be 10. 10 plus 10 plus 10. Now I have to add the 2, and I end up with 32. 32 divide equally into 4. How many would be in each group? You're right, you guys. It would be 8. 1. So it is 8 would be in each group. So when you divide 6.72, divide it into 4 equal groups, you would end up with 1, 6, 8. So you would end up with 1.68. Now let's check our work. 1.68, 1.68, Let's do the inverse operation to check. Multiply by 4, 32. There's that 32. See this 32? It's right here. 24, 25, 26, 27. Oh, look. There's our 27 right here. Now 4 times 1 is 4 plus 2 is 6. Oh, look at that. We have 6 right here. And then we put our decimal back, 6.72. Yes, we did that correctly. Now, let's use standard algorithm. 4 goes into 6 one time. 1 times 4 is 4. 6 subtract 4 is 2. Bring down the 7. Oh, look, there's that 27. So look, there's 4. Here is that 4. 4 divided by 4 is 1. Look, there's ones. There's 4 ones. There are 4 ones. Now, I have 27. 4 goes into 27 how many times? Only 6 times. And I better bring that decimal point straight up so I don't forget it. 6 times 4 is 24. Remember, we had to break that up, and we ended up with 24. Guess what? When we subtracted, we ended up with 3. Oh, look, here is that 3 that we ended up with, and that 3 was really a 30. Well, that's really a 30. Now we're going to bring down the 2, and we end up with 32. Look at that. Look at the relationships. 4 goes into 32 8 times. And yes, we were able to prove it with place value understanding, checking with our inverse operation, and using standard algorithm. All right, last problem of concept development. 20 and 800ths divided by 8. Now, we have to divide this up into 8 equal groups, so that's why this is so big. Now, we're going to divide 20 into 8 equal groups. How many can we put in each one? So if we have 20, we're going to need to pass this back. We're going to need to pass 2 10s. We have 2 10s, and you can't divide 2 10s equally up into 8 equal groups. So we're actually going to pass back 20 here. So, oops. How could we divide 20 up into each equal groups? Well, we could, and we have to do it 8 times. So once, twice, 3, 4, 5, 6, 7, 8. 8 times 2 is 16. We're going to have 4 left over. So we're going to have 4 left over. That 4 has to get passed back here. But that 4 is really 4 groups of 10. 4 groups of 10 is really 40. All right, so now we have 40 divided by 8. We can do that. 40 divided by 8, we can do by 5. 1, 2, 3, 4, 5. I can just do it this way too. 1, 2, 3, 4, 5, 6, 7, 8. And that divides very nicely into 8. Now we have 8 hundredths divided by 8. Well, that's just, I can divide that equally into 1. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So now, what do we end up with? Well, we end up with, this might look a little confusing right here, but we end up with 2, 5, 1. 2, 5, 1. 2, 5, 1. Now we could check it using the inverse operation. 8, 40, 16, 17, 18, 19, 20. And we have to put our decimal back 20 and 800ths. Yes, we know we got the right answer. Now let's use standard algorithm. 8 goes into 20 how many times? 2 times. 2 times is 16. This is that, remember our 16. We're going to subtract, and we ended up with 4 extra. Remember, here's that 4 extra. Well, that's really 40. 40, and we brought down the 0. We didn't have to add anything to it. Let's add our decimal points so we don't forget it. 8 goes into 40. Beautifully 5 times. Bring down the 8. 8 goes into 8 1 time. We have solved it using place value, standard algorithm, and we checked our answers using inverse operation. The inverse operation to check our work. Whenever you start one way and go the opposite, that's the inverse operation. All right, let's move on to our problem set. So let's just quickly review the problem set. So on problem set, use place value discs, but some of you prefer to use the actual numbers, which is totally fine as well. You can place those in there. You're going to divide this into 3 equal groups. Look, they gave you 3 boxes. So you can actually write the number 4, 2, 3, 6, 4 and 236 thousandths. And now you're going to break it into 3 equal groups. You are also going to use standard algorithm. Same thing goes for part B. On the back side, you are going to solve using standard algorithm. That means you need to place your number into the standard algorithm form. Then Grayson wrote 1 and 47 hundredths divided by 2 is equal to 2.1 in her math journal. Use words, numbers, or pictures to explain why Grayson's thinking is incorrect. You need to find her mistake and explain her mistake. Then we have Mrs. Wynn, and that's how you pronounce that, Wynn, used 1.48 meters of netting to make 4 identical mini hockey goals. How much netting did she use per goal? So dividing by 4. Esperanza usually buys avocados for 94 cents a piece. During a sale, she gets avocados for $4.10. How much money did she save per avocado? And you can use a tape diagram. This is what a tape diagram looks like, and how breaking it up to show your calculations. You have your exit ticket before we will do the debrief. Go ahead and begin.